everyone. This is the John Chappell Natural Philosophy Society Science Chat. And I'm starting a little bit early today so that if people come in at exactly 7 a.m. Pacific, they'll see that the live broadcast has already begun. So now we're just going to be waiting for people to come in. Let me go and monitor the channel here. It's going to be at YouTube at naturalphilosophy.org. And I'm just verifying that we are live now. All right, it looks like I'm the only one who's watching. Okay. And we just got the notification that we are live now. And normally we do have some people in the room before the conference. But curiously enough, we don't seem to have anybody at the moment. So until some people show up, I'm going to do a little thing I call the mailbag. Since I've been so busy lately, I've not really been able to address some of the emails that I get every day from my science friends. So I'm just going to go and have a look at those email messages. Now, once again, this is a science chat. So if you would like to actually have a comment or something, then please leave a comment in YouTube. You do have to log in with a Google login in order to make those comments. But so if you hear something, you disagree with it, then please put up a comment. Or I do see we have some people in the room, in the live room here, that if you have some disagreement, then please make sure to like wave or turn on your camera or make a private comment. And you can go to this link here, live.naturalphilosophy.org, and I can add you to the program. Okay. Like I said, this is a science chat. So I see we have Carl and Roger here. Is that Roger Wrighton or Roger Anderton? We was kind of having the battle of the Rogers in the emails, and I kind of get them mixed up from time to time. And I think a lot of other people do. I think I actually have one of these mail messages. So let me go ahead and share my screen. Let's see here. Let's just share my entire screen here. So I have to click on this, share audio, share. Okay. Be careful sharing audio, screen audio. If you have a guest, they will hear themselves. Okay, I'm not exactly sure what that means, but let's go have a look at my drafts folder here. So let's see here. It's okay. We have a question from Roger Wrighton. So like I said, I'm not quite sure which Roger we have here. But let's take a look at this word here. So this is a discussion between Don Burdell, and he makes this comment that you use the word plenum, others use ether. I used to think that the ether did have to exist, but be uniform everywhere. But then how does it act to pass light through? What gets disturbed and gives back upon passage? At best, a photon is a wavelet or a short piece of wave. Does that make sense? It seems to be very small and carries both energy and momentum, but no mass, just mass equivalent. We see individual reactions, such as a photoelectric absorption by an atom, or a Compton scatter and a partial absorption, or pair production with conservation. So a lot of these individual short events with time varying rate add up to what we call light waves. But are they really? Can light and gravity just be there, one passing and the other essentially static, without having complicated other stuff to support passage? Does something have to change and then change back for it to work? Store somewhere on something and then give back. Create tension and relax it. We have invented lots of things like wave mechanics to help explain how things might happen so we can visualize a process. That does not make it so. Others talk about tension, but this implies something moved and something stored in something and released again. How much is real? The universe is real, extremely big, apparently spherically symmetric, quite empty, and apparently still expanding. Will it stop, reverse, contract, and do it all over again? Well, that's a lot from Roger. So I was going to reply back that I would say that gravity is, in fact, a form of light. I mean, there's lots of parallels between the formulas for gravity and the formulas for light. They both travel an infinite distance. They both drop off as 1 over r squared. So I suppose that's, two major characteristics that's exactly similar. And if gravity were actually a particular frequency of light, then that would explain why it can travel infinite distances. And it's kind of like when you look up into the starry night, no matter how far these stars are, we can still see the light from them as pinpricks. Now, if you imagine that the gravity coming off those stars is mediated on exactly the same thing that the light wave is being, in fact, if it is in fact a form of light, we can see that we are actually affected. We can see the effects of gravity from all these surrounding stars because their light exactly represents the gravity field coming out of those stars, that we can see that with our eyes, and the Earth feels that as well. So every little pinprick of light out there is acting as a gravitational source that's coming directly to us, just like light. So that would be kind of the first argument I would make. And another thing that that Roger is bringing up is that Don does use this word plenum to describe, what space is. And I think this is probably a matter of terminology, because I would say that, yeah, a lot of people would just call that the ether. So, but maybe Don doesn't want to use the ether because there's lots of negative connotations with that. But I essentially think it is an ether, and Roger thinks that the ether did exist, but it had to be uniform everywhere. Although I would think that everyone usually thinks that the ether is uniform. It's more of a question of whether it's made out of particulate matter or not would be more the question. I guess maybe if you think it's made out of particulate pieces, then maybe that's not uniform, because there would still be actual blank space, and then there'd be a particle, and then blank space and the particle. So that's not really uniform. But once again, it's kind of definitional. You could say that it's uniform in the sense that everywhere you look in space, it has the same structure, right? So not uniform in a strict sense, but just like in the air that I'm sitting in, the air is pretty uniform, even though it is made out of individual molecules that are moving at something like 3,000 miles per hour. But it has uniformity in that way. But now his question, though, is how does it act to pass light through? Because I suppose if you have a completely uniform medium or substance, that would be like a solid block of steel or something. So that if it was truly just a complete solid, then how does that how does that act to pass light through it? Because even a wave inside a block of steel would cause a non-uniformity. So that's why I would think that, and this is his question here, is, what gets disturbed and what gives back? Because there has to be some non-uniformity in order for a light wave to pass through. So I would say that to Roger, well, this is actually a major contradiction to your assertion that it has to be uniform everywhere. If it was truly uniform everywhere, then it couldn't pass anything, right? So it must have to be non-uniform in order, because we see these things called like radio waves or light waves, and that definitely causes a non-uniformity. So that's, I think, a strong argument to suggest that the ether does exist, but it does not have to be uniform everywhere. In fact, it must be non-uniform in order for it to carry the characteristics. Now, he does have this concept that a photon is a wavelet or a short piece of wave. Now, I would 100% agree with that. But only in the case of light waves or light that's generated through atomic processes. Because in atomic processes, you have electrons transitioning specific integer levels, and that generates specific quanta waves. Like I said, like Roger's saying, it's a wavelet. It's a short piece of wave. And it's very small. It carries energy. I don't know if I would specifically say it carries momentum, because I think only actual physical particles can carry momentum. I would say it carries energy, but as a wave. Now, I did get another response from Draft Physics, and he's saying that light carries a momentum, which I would kind of disagree with. But I would say that his question is, well, why do you need the wave? His argument is that, well, it's a clump. And I would agree that, yeah, you can certainly think of it that way. It certainly kind of acts that way. But physically, what would your clump be, right? It still has to have some physical manifestation. I mean, whether you think of it as a constant wave, a compression wave, or a literal clump of something, it really makes no difference in your interpretation of how things work. But physically, I can't imagine, physically what that clump would be. But I can physically imagine that we have a particulate medium, and what's coming together is a space between those individual particles is being reduced and expanding. And so, to try and answer Roger's question, what is getting disturbed and what is giving back upon passage, we just have to think about, wave mechanics. Now, Roger does mention wave mechanics, and it does help to explain how things might happen. And yes, we can visualize a process, just like I said, and that does not make it so. But however, in this case, I would say it does make it so. I would argue that if you're looking for the mechanism by which light waves perhaps, and radio waves travel through, I think we can directly take the picture that we get from sound waves and wave mechanics, and I think for the most part that explains the situation. So if you have an explanation that explains the observed experiments, then why wouldn't you use it? You seem to be trying to hold on to this concept that the ether must be completely uniform at all times, and creating yourself this little contradiction in that thing cannot create tension, it cannot relax, it cannot change and back and forth in order for it to work. So I'm thinking you're just kind of creating yourself your own problem here that doesn't have to exist. So yeah, so that would be answering that. Now Don had, let's see, what did Don say here? So Don, once again, he's talking about his thing here. But I want to stop now. I want to check to see what our audience looks like today. So we've got 9 watching, and I want to check to see whether we've got any comments going on. So if you have any comments about that little email thread there, please let me know. We have Roger Anderton with us. Okay, so that wasn't the Roger Ryden. Okay. All right, as long as we got the Rogers straightened out here. Because it's funny because people will respond to the Rogers and they'll get them mixed up, and it's funny. Okay, so, and let's see if we've got any comments going on. We've got 5 comments here. So we got a bunch of hellos. All right, but no comments on that little thread specifically. All right, well, let's go on. Like I said, if you guys got some comments about, what's the relationship between, say, gravity and light, that was the main question that was being asked, or the nature of space. Is it totally uniform? Is it made out of particulates? Is it made out of something else, or do you call it something different, like a plenum? Then please let me know your thoughts there. But let's go on. I was going to read Don's email here. So it's interesting. Take your take on things. True sound waves can't pass through a vacuum, but light uses the plenum. Since the plenum is totally pervasive, light can go through a vacuum. I do believe in waves that are disturbances of the plenum. I don't believe in light particles as such. By that, I think of light as a wave until it impacts a mass, such as an atom. It is a quantum of energy equal to the frequency of the wave. This quantum has been called a photon. That gives the wave a particle interpretation. You made the following statement: I am going to argue that light is not a wave and hence does not need a medium to propagate it. If there is no wave, do you view the transfer of energy through a vacuum as being carried by a particle? So I would say, yeah, that would be the only other way in order to do that. So if light was truly a particle, then we can send the particle through absolute blank space and it can hit a wall like a bullet would. So it says shooting gamma rays is like shooting buckshot instead of birdshot. That is, the gamma ray is a highly condensed wave that cycles extremely fast in short distance and therefore acts like a particle, so much so it is possible to condense a gamma ray into electron-positron particles. Now, I would kind of disagree with that because gamma ray is something which specifically comes out of a positron-electron annihilation. And what's unique about that is that it only creates just 2 gamma rays in opposite directions, which we can detect very distinctly in our electron detectors. So it's not really, in that case, buckshot. It's not like we just get all these things coming out. It's a very specific one-shot ray. But it does kind of act like a particle. And he says it's possible to condense gamma rays into electron-positron particles, but I would totally disagree with that. He's referring to pair production, where if you shoot a gamma ray into the nearby region of a large atom, we can see it generate an electron-positron pair. So I don't believe that you can condense any kind of wave, which I would think a gamma ray is, into something physical like a particle, like an electron, right? Because there's no possible mechanism for that to happen. It's just 2 very, very different things. But what I can see happening is that a gamma ray can go in and split up whatever neutral particle is making up space. So I would say that it's not a condensation. What you're doing is that you're breaking up an existing particle, just like in electrolysis, we can break up water, which is H2O, into individual hydrogen and oxygen. I'm just saying that the gamma ray is supplying the energy in order to break up the electron positron that makes up space. I think that's a much better explanation. I really disagree with any conception that the electron is in any way made out of out of a wave. That's certainly something I am extremely violently against, that an electron is made out of any kind of wave. So he goes on to say, if an electromagnetic energy had a particle nature and propagation, its mass would opaque the ability of light crossing at right angles. This doesn't happen to my knowledge. For example, a high-frequency light emission crossing my line of sight would not block my view, no matter how intense the crossing light may be. If it were particles that were crossing my line of sight, it would opaque my view. At least it would blur my view, but it doesn't. Waves do not interfere with each other, no matter what the frequency of the crossing EME. And yes, I would agree with this. I mean, this is a very good argument against the idea that light is some kind of physical particle. One of the properties of particles is that they collide with each other, right? They have what appears to be some kind of surface, a hard area that determines whether it's there or not. And if you had these two crossing particles, then some would have to collide into each other. But we don't observe that experimentally. So therefore, I would say that that experiment argues very strongly that light cannot be any kind of individual particle or clump or have a physicality similar to an electron. But it is perfectly compatible with the idea that light is a compression wave in a particulate medium, because those things can cross each other. Waves don't actually even see each other as they cross each other, right? It's just a different angle of the compression direction, right? So once again, he's arguing against this idea that light is not a wave, that it's and doesn't need a medium to propagate it. So, but like he's pointing out that if it's not a wave, then it must be a particle. But if it's a particle, then why don't they collide into each other? It's more consistent with it being a wave. So you mentioned empty space. Space to me is solid full, crammed with EME coming and going from trillions and trillions of starlight. Go anywhere in space, you can see light. Light is everywhere, so space is not void of EME. Matter is flying abundant in space as well. Cosmic ray particles, for example. Space has a temperature. Only mass can register temperature. Waves don't have temperature until they impact the mass and heat it according to the frequency of EM emission. So yeah, this will once again be another argument that there's got to be physicality here. But waves. So you view that light is made of photon particles is a classic quantum mechanical approach and is reasonable hypothesis. I favor wave mechanics for the propagation phase of EME transmission and the quantum mechanical hypothesis for the moment the wave interacts with matter, which is a reasonable hypothesis. Both work. As to tension waves, I find in wave studies that both tension and compression operate. Both are needed. You cannot have one without the other. To prove this would require me modeling a wave. A wave has two components. The electric part of the wave is centrifugal. The magnetic part is centripetal. The magnetic component surrounds the electric when there is an electric. Does this have any bearing on what you mean by tension waves? Now, I'm thinking maybe this has to do with Cornelius's main shtick, which is that everything is tension, perhaps. But I would be in more agreement with Don that tension is just the affinity of one particle for another under a separating force, and but I would not agree that we need to model a wave and the wave has two components. He's saying the electrical part of the wave is centrifugal and the magnetic part is centripetal. But if you take a look like a wave in sound or a wave in the ocean, there's no electric part and there's no magnetic part. And I don't know that the wave has anything to do with things which spin around and create outward forces, and that would be the centrifugal and centripetal forces. I like to try and keep things simple. I mean, if you think it's going to be a wave, they should pretty much treat it like waves that we know about, like sound waves. And sound waves don't have two parts, and are certainly not orthogonal to each other, and certainly they're not electric, and certainly they're not magnetic. And even if you did, then you would still have to figure out what makes up the electric field and makes up the magnetic field. I think it'd probably be a lot simpler, and that's my approach, being that the electromagnetic wave actually has nothing to do with electric or magnetic field. I think it's a misnomer to say that it's an electromagnetic field, because it's more like, I keep on trying to argue, just like a sound wave, essentially. So let's see here. Once again, I'll stop again. Let's see if we've got some comments here. Okay, good. We have some comments here. And we've got other people in the room here. Once again, if you're in the room here and you want to speak, just turn on your camera and wave at me. Okay, so we've got a comment here from Protext. Have you heard about Mach principle? Well, in terms of maybe you're Mach saying that everything that like I feel like right here is due to all that stuff that's out there, right? Now, me personally, I think that's true to a little bit. It's like all of the gravity we feel on the Earth is due to all the gravity we see from our little pinprick stars in space. But I would say that in my room here, that really has no effect, I would say. What's more important is your local effect, is your local, let's see, I'm going to stop sharing here for a second. What's more important is your local environment, and I think Mach took it a little bit too far. Let's see here. We have a comment from Superfin. It has to be particles, pretty tight ones considering the speed of light, but they must be there. So once again, the whole argument in the email is that it couldn't be particles, because if they were particles, then particles collide with each other. So I would think that the point that Don was making is pretty true. So I was wondering, why would you think it has to be particles versus a wave, or like what was discussed in the email, a wavelet, right? So normally radio waves are totally continuous, but one of the thoughts is that when we're dealing with specifically light phenomena, the thing that's coming out of a light bulb, is that we're dealing with like little wavelets go boom, just one little bump. Now I would add that that the amplitude on any light wave is actually exactly the same, that there is no change in the amplitude from any light wave, because any light waves are created by these quantum effects from electrons jumping from one integer level to another, and that creates a fixed amplitude wave. And that the reason why we get things that kind of look like particles, I think it looks like particles because it seems to come in little quantized minimum energy packages. And that's why, the photoelectric effect was kind of one of these experiments that said, oh, well, light must be a particle, right? because we see it, it doesn't seem to depend on, the brightness of the light, which would kind of be implying that there's a different amplitude there, right? Different. Yeah. But I don't think it's a different amplitude. I think that every single light wave is of exactly the same energy content, and that's what we actually call Planck's content. Only the formula is energy equals h, which is Planck's constant, times frequency. So h is actually the amount of energy contained in any one light wave of any frequency. And the only reason why the energy is greater is because you can simply fit more of those individual energy packets into any given bit of time. And actually the formula E equals HF is actually the amount of energy delivered over one whole second. So if you look at the dimensions, that's what it means. It doesn't mean that an individual frequency, like a red light wave, it delivers X amount of energy per wavelet. That's the amount of energy delivered to a surface for one full second, because it's cycles per second, right? So you have to use at least a whole second to do that. Let's see here. Need to zoom in on your browser screen. Well, perhaps here. So you said space possesses a regenerative energy field, dark energy. Baryons evolved form and processes optimized for exploiting, consuming dark energy. Baryons convert dark energy into atomic activity, atomic forces. Well, that's kind of an interesting idea. Now, me personally, I don't like the concept of dark energy at all. And perhaps Questing is using this in maybe a different way. I mean, you could call, dark energy is like any energy you don't know about, really. Theoretically, in mainstream physics, they're talking specifically about the energy which is actually causing the universe to rapidly expand or explode away, right? But that doesn't quite sound like what Questing is talking about here. Saying space possesses a regenerative energy field. And maybe that gets to a little bit about, what is giving and taking, what is moving back and forth, what is changing in order to transmit light waves. But I would generally disagree with, baryons convert DE into atomic energy or atomic forces. I mean, unless you're going to tell me what dark energy actually is, I really can't judge as to whether it could do that. I mean, you might as well say green little men. So, green little men baryons convert green little men into atomic activity and atomic forces. I mean, it's saying the same thing. And if I say that, then it kind of sounds ridiculous, right? So, but now if you would like to clarify that, then, please come on live.naturalphilosophy.org, and I'd love to hear you, talk about it. Let's see it. So, life exploits energy potentials in the same way. Like trees, for example, they evolve form and process optimized for exploiting the energy potential that allows them to exist. Well, certainly I think they do absolutely do that. They exploit the energy potential coming down from the sun, and they do chemical processes. But you're saying something about, how subatomic particle baryons exploit that energy potential. All right, let's see here. So anybody in the live room have any comments? I see we have 4 other people here today. And we have 13 viewers. Excellent. Let's go on. Let's go on to our next email message here. So that is answering that one. Okay. let's see here. We have a question from David Taylor here. So this is quite a long thing, but it's kind of interesting here, but I won't go over all of it. So this is to John, Roger, and me. So it says, I think when it comes right down to it, but everyone has a weird idea about light, EM, photons as having different degrees of wave particle aspects. Please take a chance on some of mine. I have professionally published papers on aspects of them and working on a fourth. I don't know if you're going to ignore me because what I'm going to say involves both relativity and quantum physics, though they are aspects of those things that have never been said before. I will admit there was a time when I absolutely dismissed the whole idea of ether and or the plenum. Everybody knows that light can pass through an absolute vacuum because it has been proven in laboratories. I was wrong in some ways, but right in others. The entire ether plenum gang is the same, right and wrong. So light cannot move through space without a medium to conduct it. There is no possible way to prove that now because we don't have a way to create a quantum level vacuum here on Earth. But wave aspects of EM will begin to argument for it. So I suppose that would be, I mean, he's bringing up the fact that if we could create a true absolute vacuum, that would be a region of space which light would not be able to pass through. You would see a completely opaque to radio, magnetic, gravity. You would see a region which has absolutely no properties, and then you could compare it against, what we consider a normal vacuum, where light and all this other stuff can pass through. And you say, aha, therefore space must be filled with this medium, right? That would be one way to prove it. Of course, we can't create this region of space which doesn't have anything in it, and we can't measure its properties, largely because we don't have any kind of container, apparently, that we could do that. Although, maybe someday someone will invent some way to do that. But yeah, right now we can't prove it that way. So interplanetary, interstellar, intergalactic space could not be an absolute quantum level vacuum because we can observe body formations throughout our universe. That is the way I interpret the fantastic variety of EM sources everywhere. Yeah, and all the stuff that's made up. And there's an unrecognized parallel between special and general relativity time distortions. Then we have some equations here. And he says that this matches the EM signature, the cosmic background radiation exists absolutely through our universe. Though almost all of us say reflexively it is not true. I'm not sure what he's saying, not true. The CMB is nearly homogeneous. Both the small intensity and wavelength argue against that homogeneity. Yeah, I would say that the cosmic background radiation, even though it's a small amount, is highly irregular. He goes on to say, all waves have particulate aspects. Just think about a wave crashing on a beach. There are moments when there is energy being transferred, the crest and the trough of the wave, and when there is no energy being transferred, the halfway point between two. So there are water-on particles that transfer energy in waves that are parallel to quantum level bosons. This does not mean that the water-ons or bosons waves are particles. They simply have particulate aspects. Yeah, I guess there's an important part here that waves are made of actual particles. So, and the things that are actually doing the action, like moving the sand on the beach, is actually due to a particle-to-particle collision, right? So, although the wave itself is not a particle, the actions that waves take is due to them being mediated on particles. And I would say that the only time you can, affect a particle is basically by kind of colliding with it. Now, maybe for like things like electric fields, maybe you don't necessarily have to do that. But I would extend to say, yeah, even in that case, whenever we see particles come together, ultimately it's because something is running into it, right? Now he goes on to say, you can apply the same reasoning to matter particles. We all know that matter is not continuous, it is particulate. We started with atoms, then subatomic particles, then subnuclear quantum particles. I don't know if there's something still further down. We have established absolutely that quantum particles exist, but we can't say absolutely there is nothing below them. We are using subatomic particles to create instances where quantum particles exist, and we detect and measure them. To be certain there is nothing below them, we would have to find a way to manipulate the up, down, strange, charm, bottom, and top particles in a particle accelerator in a relativistic kind of way. There are also particles smaller than the quarks. The leptons, electrons, muons, taus, blah, 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 are halfway between the bosons and the quarks. So yeah, I would agree with that. Atoms are particulate, and but is there something further down? And like the quarks, right? Are those further down? And where do the leptons, like the electrons, fit into this whole picture? Because apparently electrons are not made out of quarks, right? So if electrons aren't made out of quarks, then what are they made out of, right? And no one's been able to break that down into anything smaller. So in that way, if you've got that statement that we've got this particle, you can't break down into anything smaller, I would claim that that must be the fundamental particle then. And that other things like the quarks and all these properties of quarks are actually a made up thing that I would disagree. I mean, I have a paper that says there are no quarks, there's only electrons and positrons. So if you're looking for an answer for what is below everything, I would say the thing that's below absolutely everything is actually just the electron level. So that's fairly obvious level to base it on. And it's the electron is not made out of anything, is not made out of waves, it's not made out of toruses, it's not made out of tension. An electron is in fact a fundamental particle, and we should consider it as such. At least that's my opinion. So we have something else here. If you accept my EM medium wave shift idea, I'm not sure if I read that shift idea, you no longer have to give in to either universe expanding or contracting business. The idea doesn't really make sense anyways. If the universe is expanding and expanding at an ever increasing rate, how did the singularity ever come to be? But there are mini bangs all around us. Sagittarius A object expelling H1 atoms continually. It is at the center, so it's likely the oldest object in the galaxy. Why is there any H1 left? But think about SOs. Their primary relativistic distortion is time. Well, not time, actually it is the velocity of waves. The only evidence we have for time distortion is the frequency of waves, but waves can move more slowly. Light doesn't move as quickly through dark glass as it does in close to Planck level vacuums or when they are under relativistic distortion. There is also a matter of mass increase. As particles increase velocity in the accelerator, the closer it gets to C and the more massive it becomes. That is not because of some magical relativistic effects. In some ways, it is simple Newtonian physics, and the boson level EM approaches and strikes the particle. That energy particle increases the velocity of matter particles because the boson is moving at light speed. It can never move the particle faster than light speed. So the particle's acceleration gets lower and lower, but the energy just can't disappear. You don't need Einstein physics to argue that conservation of energy is one of the most fundamental principles in all of physics. So if it doesn't disappear and is accelerating the object at slower and slower rates, where does the energy go? So I don't know about this having to do with expanding or contracting. I don't know that the medium has anything to do with whether we have an expanding or contracting universe. And if we have an object Sagittarius H that's constantly expelling H1 atoms, why is there any H1 left? That would be kind of saying, like, if you're looking at our sun and saying, why is there any hydrogen left? Because that thing's constantly converting it into helium. I would say, well, it just hasn't run out yet, I guess. So we just really don't observe things long enough to say that, it's where it is in its lifetime. Now, maybe if we were around for like a couple billion years, we could say, oh, well, that should have run out, but we may just have really a big supply. But he does bring up this interesting point about in relativistic theory that that the mass increases like an accelerator as we accelerate it, and this is one of the arguments that you can't accelerate a particle efficiently past the thing that is propelling you. So if I put a bunch of fans on a skateboard or something, I could put like 10 fans on it and it would accelerate it at a certain rate. But as it got up to the speed of where the air is being blown, I could put 100 fans on there and it would barely get faster. Really, it can only get as fast as the air that's coming out of it. So that's kind of an interesting argument. But in talking with, say, Bill Lucas, who does these kinds of experiments, you find out that you don't really measure the energy by the speed. You measure the energy by how much energy it impacts in a target with. And if you do that, you find that the energy increases very disproportionately to the actual acceleration. That's like exponential to the speed of the particle. So if the whole skateboard and fan argument were the case, then the maximum speed, the maximum energy that the particle would have would be fixed. And every single time you see it hit the particle, you would see it only having a fixed amount of energy corresponding to like 1/2 mv squared, where v equals c. But we actually don't see that. We see the energy being much, much greater. So something else is going on here to cause it to act as if the particle had increased in mass. But that's just an interesting thing to keep in mind when thinking about that whole relativity thing. So you can answer that with what I think is the most fundamental equation of all of physics, E equals mc squared. Both matter conservation and energy conservation are very old laws. Conservation of matter was first proposed by Michael Lendeloff and later rediscovered by Antoine Lavoisier in the 18th century. The idea of conservation of energy came much earlier. Thales of Miletus had inklings of conservation of some underlying substance of which everything is made, but it was not nearly as easy to establish. Galileo came up with arguments in 1639, and the favorite of your gang, Isaac Newton, in 1689. It was probably added to in trivial ways between Galileo and Newton. The result expanded in our non-trivial ways after Einstein and Newton we see around us now. So if both Einstein and the other gang are right about matter energy conservation, then there must be some kind of equivalence between them. I am personally unsure about E equals mc squared, but not the principle, only the value and constants in the equation. For example, the kinetic equation is 1/2 mv squared. That is not consistent with Einstein's energy equation. Einstein got E equals mc squared from a binomial expansion of his mass equation. Since it is a square root equation, it is not something you get an absolute value from, but an infinite number of expressions, each of which gets closer and closer to the value for the root, but not absolutely accurate. That is just the way imperfect square roots work. I've tried several times to get it myself, but never seem to get close to E equals mc squared. but it is also never seems to get close to 1/2 mc squared. It seemed to be E equals 0.5, the blah, blah, blah. But I couldn't find a way to reason that, so I gave up. But it would be a way to make the kinetic energy and the energy equation consistent by picking the halfway. Kinetic energy would be 1/2 blah, 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 and the matter equivalence would be blah, blah, blah. So he's kind of questioning this whole idea. Let's see, now someone suggested I need to make the font a little bit bigger here. So yeah, let's do that. Maybe you could actually read this if I did that. Because now it's so big, I can't control it anymore. So that's not good. Yeah, now everything is bigger, but okay, but I think this discussion is interesting. So he is questioning whether it's really E equals mc squared. Maybe it should be this other formula here. You know what? It's 1/2 to the raised to the power of half mc squared. So he's questioning the actual constant. You know, it's not, but I would say that I think that this actual formula has been established in the case specifically between positron and electron annihilation, where this has been carefully measured. However, I think that's actually the only experiment in which we can precisely measure the energy of matter particles theoretically being converted into energy. They have done experiments to measure this formula with like lithium decay, and it's not exactly E equals mc squared. You know, it's off by a good maybe 20 or 30%, which in physics is a gigantic difference. So there are definitely experiments saying that it's not strictly mc squared, but I don't think it's anywhere close to like 1/2 to the 1/2 mc squared or anything like that. It's generally speaking pretty close. But, you know, he is bringing up this other example of the kinetic energy equation, which is 1/2 mv squared. Now, me personally, in my own theories, I explain this very simply because I say that the energy that is being released with a positron-electron collision is actually the kinetic energy of the components. So if you have an electron and it's heading at a positron, those things are attracted by the Coulomb force, and the Coulomb force at very small distances essentially goes to be infinite, right? So there's a lot of energy and force available to accelerate those two particles at each other. Now, I believe the reason why we have the speed of light in this formula is that physically nothing can travel faster than the speed of light. I think that that's something that's generally accepted by mainstream. And so no matter how much force you can get between a positron and electron, the maximum speed it could possibly travel at natural energy levels is going to be, you know, c, or very close to it. There have been some arguments that, well, it could never reach c because nothing can reach c. I would say that the electron and the positron in this tiny example does actually reach c, because experimentally we see that the amount of energy is equal to the amount of kinetic energy contained in the electron, which would be 1/2 mc squared. And then you add that to the energy coming from the positron, which is also has 1/2 mc squared. They collide together. The kinetic energy goes to zero. That energy, by energy conservation, has to be released somewhere, right? All this kinetic energy just cannot suddenly disappear. And how does it get converted? It turns into a gamma ray. whose energy is 1/2 mv squared plus 1/2 mv squared. Therefore, the total energy to be released is mc squared. And that's where I would claim we're getting mc squared from. Not from some weird binomial feature. I think it's actually a direct result of the kinetic energy equation. And it's not any conversion of matter to energy. It's just you've got a positron, electron, just like my hands slapping together. We hear a loud clap. That's conversion of the kinetic energy in my hands into sound energy. And that is exactly what's happening with the positron-electron collision, is that we're getting basically sound energy. And I claim that all light phenomena, gamma ray, whatever, is actually exactly like sound waves. So my hands clapping together is an excellent example of the conversion of kinetic energy into sound, into wave energy, right? Like that, right? And that's exactly what's happening. The amount of energy is 1/2 mv squared of my hand plus 1/2 mv squared of this hand. So total energy released during my clap is mv squared. Or if my hands could travel at the speed of light, it would be mc squared, right? And there's really nothing to it. I mean, I keep on bringing up to these people that you have to account for that kinetic energy of the collision, right? Because because where does it go? I mean, it has to go somewhere, right? When I bring this up, some people say, oh, the electron and positron slow to each other so that they're at almost zero velocity, and then they collide, and then they're converted into their mass equivalent. It's like, what miracle of physics allows that to happen? What would cause them to slow? I mean, when you consider the near infinite amount of force between the positron and electron as they get close, what would cause them to slow down to zero velocity? I mean, that's just inconceivable, right? And if you look at how much kinetic energy should be available, it's mc squared amount of kinetic energy that should be available, and therefore none of the matter could have possibly been converted into energy because it just didn't show up. If it did, it would show up as more energy. It should be like 2mc squared or something like that. But we don't see that. We only see the kinetic energy present. So that's the mail message from David Grant Taylor. All right, so I'm going to stop and check to see whether we got some comments about that. So we have a comment from Alistair. And I see we have Hans here. So Hans, if you want to speak, just give me a wave or something. I can see your camera. So Alistair has a comment here. So it is a wave or a particle. Are plums equal to apples or equal to oranges? Plums are equal or equal. Well, I'd say the plums are not equal to apples or equal to oranges. So your point is that, is it a wave or a particle? Oh, I would say it's strictly a wave. That's my opinion here. Okay, let's see here. We've got some comments here. Let's see. More comments. Let's see here. Yeah, we have a comment from Super Fin Guy. Say, nice word salad, right? And in some ways, let me see. Let me stop sharing here while we're doing comments here. And let me turn off my obnoxiously bright light behind me. There we go. So I'm working on my indoor garden back there. So trying to grow some peas and stuff like that. So I'm not growing marijuana or anything like that. I've got some veggies going on back there. Okay. And yeah, talking about salad. Yeah, I got some Swiss chard there for salad. So, but this is kind of a frequent criticism of people who, in the distant world, that just getting really wordy and putting things together, but it may not necessarily mean anything. So physics is a highly ordered, complex system. You need a mechanism for generating complex systems. Darwinian evolution. Well, certainly we have complex systems. But the question is the fundamentals complex? And I think no one would disagree with you here that we need mechanisms for generating complex systems. Although it's like, did Darwinian evolution have anything to do with the creation of, say, the uranium atom, and or any of these other physics, or like the magnetic field, or anything like that? I would say no, but certainly for creation of systems as complex as biological beings like ourselves, certainly some kind of Darwinian evolution was involved. And my only shtick with the whole evolution thing is that it's not a random process. Evolution happens because something is intelligently picking the most desirable thing, That's why, when we go looking for mates, we're looking for specifically the prettiest person, the most attractive person there is, and that's definitely an intelligent decision. And that intelligent decision is what's causing your progeny to succeed down the line, right? It's never just something random, right? Evolution is not a random process. It's driven by the intelligent selections of the creatures who are involved in this evolution. That would be my little shtick on that. So Stefan asks, what about the Compton effect? This is direct experimental evidence that light is a particle. Okay, let's look at the Compton effect. So I'm going to look at the Compton effect. Light is a particle. I thought you were going to bring up the photoelectric effect, but let's look up Compton effect. All right, let's see here. From the source of truth, Wikipedia. No, I don't think that this is it. The Compton effect. No, I think we're looking at Compton scattering. Okay, Compton scattering as a scattering of photon by a charged particle, usually an electron. It results in a decrease in energy, increase in wavelength of the photon, which may be an X-ray or gamma-ray photon, called the Compton effect. Part of the energy of the photon is transferred to the recoiling electron. Inverse Compton scattering occurs when a charged particle transfers its part of its energy to a photon. Now, isn't this just the photoelectric effect? Not exactly here. Let's see. Compton scattering is an example of inelastic scattering of light by a free charged particle where the wavelength of the scattered light is different from that of the incident radiation. In Compton's original experiment, the energy of the X-ray photon is very much larger than the binding energy of the atomic electron, so the electrons could be treated as being free. The amount by which the light's wavelength changes is called the Compton shift. Although nuclear Compton scattering exists, Compton scattering usually refers to the interaction involving only the electrons of an atom. The Compton effect is observed by blah, 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 further verified by blah, blah, blah. The effect is significant because it demonstrates that light cannot be explained purely as a wave phenomenon. Thomson scattering, the classical theory of electromagnetic waves scattered by charged particles, cannot explain shifts in wavelength at low intensity. Classically, light of sufficient intensity for electric field to accelerate the charged particle to a relativistic speed will cause radiation pressure recoil and an associated Doppler shift of the scattered light. But the effect would become arbitrarily small at absolutely low light intensities regardless of wavelength. Thus, light behaves as if it consists of particles if we are able to explain low intensity Compton scattering, or the assumption that the electron can be treated as free, is invalid, resulting in the effectively infinite electron mass equal to the nuclear mass. See comments below. Compton's experiment convinced physicists that light can be treated as a stream of particle-like objects, quanta called photons, whose energy is proportional to the light wave's frequency. Okay, let's think about that. So there could be like a lot of holes in here, already explained by this, that you can't, specific electron as if it were completely free. And we're talking about low intensity particles here. And they're saying that because no matter how low the intensity is, it's still able to do this. So let's hear. And it changes frequency. So Compton scattering at the graphite target on the left is lit past X-ray, blah, blah, blah. And the energy of the scattered photon could measure total energy deposits, not the energy of single scattered photons. So we have these shifts. So number one, I would say that I'm not quite sure why this experiment is so convincing, considering that, it makes this assumption that the electrons are free. Quite clearly, electrons are not free if they're embedded in a graphite target. So that has to have an effect at low intensities. It must. I don't know how they could think that it wouldn't. So the other thing here is that we're talking about a wavelet effect here. Once again, that all of these kind of things like the X-rays as a specific photon light phenomenon come out at fixed quanta, and they interact with their target as individual fixed quanta. And I would predict that no matter how you lower the intensity, it's still a fixed quanta against a target, right? And it should still react against that target the same way, regardless of intensity, because the amplitude of all these X-rays are going to be equivalent, and it's just a matter of how many of them are impacting the surface. And there seems to be a reasonable explanation for why the shift occurs at higher intensity, so-called, because maybe we can just see that. So I would say that there's enough holes in this theory that this does not conclusively prove that an electron is a particle. And if that light is a particle, and if it is a particle, then why does it not collide into each other? This is still a very, very much major blocker to this whole idea that light is a particle, right? No matter what other things you can say, you have to address that opposite observation that light does not collide with each other, does not collide with itself, I should say. So, but a good question. I've not really been familiar with the Compton effect, but let's see here. A natural organizational principle, Darwinian progression, is the only method nature has capable of generating highly complex systems. Well, yeah, probably I would agree. So it's either the method to your master madness here. So question, you have a lot of explaining to do then. Let's see here. So Super FinChan guy says that Compton effect can be explained by resonance. I think that's what they were saying in the wiki article, I think. But the thing that they were trying to question was that if you get to really, really low intensities, this thing still happens, and that they're saying that only particles could do that. I don't think so. So I have detailed explanations, but there is enough info above to loosely frame a scenario. Well, we can all loosely frame. It's perfectly fine. So sound wave is longitudinal and light is transverse wave. That is basic of EM theory. Oh, well, I definitely got something to say about that. Okay, so definitely sound wave is longitudinal in the sense that it is like a compression wave, I suppose, right? I think we all, and they say that light is transverse wave. Well, how do we know that? I mean, just looking at light, it's like, how do I know that that's, if there's anything transverse in it? Now, transverse meaning that there is something, I don't know, going in the up and down direction relative to the direction of travel, right? That's, now people naively perceive the light wave as being like a rope, and that's a transverse wave, right? In order to have transverse wave, you actually have to have some kind of difference in a medium or something to detect the transverseness. And generally speaking, the only number one reason why we think light is a transverse wave is because it can be polarized, right? They're figuring, well, given your ropes through the picket fence analogy, you know, only transverse waves can be polarized, right? And I'm saying, no, that's stupid, right? That, first of all, light is not a rope, okay? Light, it's not in anything, way, shape, or form, a string that you're waving up and down, right? So it can't be that, right? If you think about it, if you believe that, then I got a bridge I'd like to sell you, right? Because there's just no way that light is a rope on that you're waving up and down, right? And there's no way polarizer is as simple as a picket fence, right? Now, maybe in elementary school, learned that and you just accepted that and go, yeah, and if I turned the picket fence this way, it would completely cut off all the waves and then there would be nothing to go through. But no, that is a form of polarization, but I would argue that has nothing at all to the polarization we see with light waves, right? So that would be my argument, is that, is light a transverse wave? I would strongly argue, no, it is not a transverse wave. I mean, transverse waves are things like earthquake waves, where like the whole ground moves up and down. It's like, well, what would that be for a light wave? I mean, we know that light waves are very point-like. I mean, they are like, they're particle-like, right? And they do act like little bullets. And, you know, how can you have like an earthquake wave in something the size of a bullet, right? That just doesn't work, right? And you know, we have had discussions previously in the science conference about, you know, how does polarization work? And I actually got another response from the draft physics guy about polarization, and I think, you know, there's a lot that we can agree upon actually, and these discussions, I guess, kind of help to characterize that. But definitely, I would say, look at your reasons for thinking that light is transverse. I mean, if it's only polarization, that's really, really weak evidence, because you don't know, I mean, you're not even providing yourself an actual mechanism for how the polarization works, not unless light is like a rope you're waving up and down, and it's clearly not that, right? So you've got to think yourself, okay, that was silly, okay, for me to think that light was transverse just because it can be polarized, right? What all that means is that something in the light wave does have a transverse component in it, clearly. I mean, there's something where, you know, it can be rotated at any particular angle and you can pick it up, right? It means it has some transverse component. There is something that has a transverse component to it, but it doesn't mean that the wave itself is transverse. It's like my analogy is like if you look at waves crashing onto the beach, so those waves are clearly longitudinal kind of phenomenon, but you see the whole wavefront running parallel to the beach. That has a transverse component. I mean, it's transmitting, you know, you could draw a line and say that is the transverse component of that wave. But, you know, we didn't have to say that the ocean wave was transverse, although ocean waves are kind of truly transverse because we can see the crests move up and down. So, but that's where we get into all kinds of troubles here. But all of those waves are still mediated on a particulate media, right? There's no, as we've gotten back to the start of the discussion of, how is the medium completely uniform? And, if it is, then, how could it possibly host waves? And the answer is it can't. So therefore, it must be non-uniform. So we have a question from Stefan. What do you mean by resonance? Did he ask a resonance question in here? Oh, he's saying that that the Compton effect can be explained by resonance. I think the wiki article went back to explain that that it's something about when it hits, then there's a resonance, and then that changes the frequency of the reflected wave. Because the difference here in the Compton effect is that the frequency comes in at one frequency and it leaves at another. So, and there was an explanation about that, I think. Not unless he meant something else, but I think that's what he meant. A wave has to be a wave of something. Yeah, I would agree. A wave has to be a wave of something physical. So if we think light is a wave, then there must be some medium that exists in what we perceive as a complete vacuum, because we can shine a light through that vacuum. It goes through really well. So if that's really a wave, then there must be something there. So David asks, can you explain other theories for light that aren't ether? Well, clearly the alternate for there being ether is there being just blank space, and that light is a particle. So if light is a particle, then it's like an electron, and I can shoot an electron through a vacuum of space, and it goes from the emitter to the screen, and it hits the screen. We see a little blip of light, and that is one other, that would be the most obvious popular theories for light that, that aren't in ether. Another theory would be like Bill Lucas, who just postulates that the electromagnetic field itself is fundamental, right? So all that stuff about light going from one place to the other, that's just what space is, and that God is in charge of that, right? So physical ether, there's not any particles, it's not made out of any mass. We just have the electromagnetic field, the thing that comes out of electrons, as being the thing. It's like space is made out of the electromagnetic field would be that kind of theory. Although I would say that is still an ether, right? Still a pervasive something that fills all of space, that permits the transmission of electromagnetic energy. But the splitting hairs. But that would be at least a non-material theory for ether. But those are the ones I know off the top of my head. If anyone else has any others, that would be fine. So in order for electrons to be scattered, the light has to be of a given frequency. I think we're talking, are we talking about the photoelectric effect here? Maybe. I mean, what's interesting about the photoelectric effect is that, first of all, you have to have the right frequency. If you have a lower frequency, nothing gets ejected in the photoelectric effect, right? So number one, you have to have enough frequency in order for it to happen. But this is one of the reasons why they think that it's a particle, because the argument is that you have to raise the intensity in order to, or is it the other way? Okay, I'm getting a little bit confused about how that, what the argument is that causes light. But if you have a more specific equation, maybe a question, then you could maybe state that about why you think that light has to be a specific frequency. So Duke says physics without math or operational definition of terms equals physics poetry. Well, I suppose that's true. I mean, to a certain extent, as a theoretical physicist, you know, I have much in common with the science fiction writer, say, right? Like both of us are just, you know, making stuff up, right? Making stuff up, right? Now that's where the experimentalists come into play. So us theoretical physicists propose some crazy theory about like what space is made out of. You know, so I propose that space is made out of a positron-electron field. Okay, so I propose that, right? Now that is essentially science fiction, just like someone proposes that you could have a transporter in Star Trek, right? That's just words, right? Or I could say that space is made out of little green men, and that would make just about as much sense, right? But the experimentalists, they will then apply math, you see, because we know, say, the physics of electrons, and you can do math and say, well, if that's true, then there'll be this much charge here in space, and you can calculate if there's an experiment we can do to prove that either right or wrong. So we start out with the theory that translates into math, and then that math is theoretically confirmed by experiment, right? I think those are like the three legs of the chair of physics, and all three must be present to win. Although nowadays, I think it's like, right now we forget about the, we just concentrate on the math part, and if the math part makes sense, then we consider that being true, like, you know, string theory, which was just basically all math, but there's not a single experiment to back it up. That chair falls over, okay? But I think that's interesting. So Duke says H is not amount of energy. It is energy times time product called action. And really, I would once again violently disagree with that. I mean, I know that what, you know, this is the mainstream interpretation of E equals HF, right? Energy times time. And H really is an amount of energy. It's measured in joules. It is an energy. And it's an energy delivered over a period of time, namely 1 second's worth of time. So I would I would ask you, Duke, it's like, if it's not an amount of, if energy is not an amount of energy, then what is it? I mean, definitely the result of the experiment is energy, and it's an E, it's energy, right? And F is a frequency. So whether it's 100 or 1,000, that just means 1,000 cycles delivered per second or 100 cycles delivered per second. And then you just multiply that by the fixed amount of energy that each of those quantic contain, which is H, and that state that is an amount of energy. Then you get the total amount of energy delivered over that 1 second. So we can agree or disagree X as long as we don't define X, so we know we are talking about the same thing. Well, that doesn't make any sense to me particularly, because definitely we have to define X. I mean, this is one of the main problems when discussing things with dissidents, that X means one thing to one guy and X means Y to the other guy, but they're still talking X. And everyone just like talking in circles, and it's like, pfft. So I think it really is important to try and to do that. So we have a question. So to David DeHilster, how would they work? How would what work? I think the last question you asked was about other theories about light. So I think I gave you 2 or 3 different ones here. And so Stefan has a comment here. It says, hello, David. Can you give me the name of the documentary you mentioned last night in the live stream? So, yeah, so David, if you could put that in there, you could answer that question for Stefan. So why are we reading posts rather than fostering discussion among participants? Well, actually, I would like to foster discussion among participants, but in order to do that, I need you guys to come into the live room and wave at me so that I can talk to you. So really, there's only one person in the live room right now, and that's Carl. And see, I could add Carl to the stream here. And if Carl wanted to say something, you could say something. Hey, Carl, why don't you say something just so we can see that you're there?
It does.
See, it's working. So since you're here, and I think people are getting tired of hearing me talk, did you have any comments about the emails and the things that were being covered?
Well, there's been a lot of discussion. Hang on a second. My own feedback is really loud. Well, I'm going to mute myself on my own computer. But that makes it hard for me to hear you as well. Anyway, a lot of the email discussions have been through a lot of this pretty thoroughly already. And I don't see a lot of migration of people's opinions, how they think about light, what it is, whether it's a wave or a particle or something else. Ether, no ether. People have their ideas and they seem very attached to them.
All right. It's a little bit hard hearing what you were saying there, but thank you for your contribution. So actually, we're kind of getting used to this new system here on StreamYard. And previously in Fuse, everyone could just kind of break into the conversation and talk anytime they wanted. And that kind of fostered more of a conversation, which is what we're actually trying to do here. We're trying to convert. This is a science chat. This is like your coffee shop place to discuss any ideas you might have. But I'm just finding it a little bit difficult to get people to show up in my live room and participate. So we are left with just going through your comments here and doing it that way. So, but we're always trying new different things here. So let's see here. Choose an individual tab. Okay, using Chrome. Yeah, so we do have a comment from Michael and Teskey is that we should return to voice interactive meetings had as many participants with Fuse. So yeah, that would be kind of like that. I'm a little bit struggling with getting people to come into the live room, so it does kind of end up being just me talking. Although as much as possible, I'm trying to express the opinions of other people's and say the emails. So I think we've heard from other people because I've been reading their emails and then kind of responding back to those questions as much as I can. But we do have some lively comments here, so that's good here. So life doesn't need intelligence to evolve. Now, I would disagree with that. I would say that life totally needs intelligence to evolve. That intelligence being that selection. I mean, even if you're just a stupid bacteria and you're in an environment that kills you, well, I guess that's not really a good example. But in that case, it probably didn't need, the bacteria probably didn't need to think about whether they should survive or not. And in like that case, but but it certainly in the case of intelligent beings, certainly we needed intelligence for that. As soon as you got big enough to be like an ant and you could decide whether you should mate with this or that, then that would be where intelligence was involved. But I would have to agree, okay, so if you're at the level of like a bacteria, then maybe you didn't need to evolve to get to that point, or a virus or something like that. That was just a matter of surviving in your environment, right? So, okay, so I would give you that. So Cornelius said the amount of energy in a photon is relative to its wavelength, not frequency, as the article claims. Really, I would say that the amount of energy is relative to either its wavelength or its frequency, because those two are intimately related to each other, right? You can link without changing the frequency. So I think you're kind of splitting hairs there, I think, right? Not unless you disagree with me, right? So the rope as being the only form a transverse wave can take is a misconception and misrepresentation. Well, yes, that's true. I mean, I would say that that's actually my point, that a transverse wave is even pictured that way is not a very good thing, right? I mean, one of my major bugaboos about this whole transverse wave is that I couldn't conceive at all how a light wave could transmit as, say, a transverse wave, like an earthquake wave, like Akimbo. You know, he literally thinks that it travels like an earthquake wave, and the whole ground moves up and down in order to transmit that. Or or the only other way I can think of it is if you had a bunch of balls and you put them on springs in a three-dimensional thing, and if you twinged one end of that, set of balls, then you could see a wave go up and down amongst all those balls, as another way that it could happen. But all of these things just seem to be really, really difficult to visualize. But my main point is that whatever light is, it's not a rope. Is not a rope going through a picket fence would be my main thing, right? And it's extremely misleading to represent light like that. So I would have to say I would agree with you in that. So transverse waves do propagate in solids as shear energy waves. Yeah, as I explained, some people think they travel like that, but but those waves are like huge, right? They're like earthquake waves. And that's clearly not what a photon of light is like, right? There's no way you can have this gigantic shear wave and it acting like a gamma ray, which is a little point bullet-like thing, right? So the Compton effect is related to the photoelectric effect, or what happens to the light after it hits the electron. Yeah, it seemed like that. That's why I was looking at the wiki. I was kind of confused as to whether the Compton effect was the photoelectric effect, but it seems to be something a little bit different. So in the photoelectric effect, the electron is emitted as well. Yes, that would be the key thing here. Let's see here. Oh, I need to put on my headset to prevent feedback. That's probably true. Someone should have mentioned that a little bit earlier. Okay. Hopefully that's better. I've got this right. Let's see here. So Quest is on a evolutionary kick here. If life needed intelligence to evolve, it never could have started. Yeah, I would probably agree. Like I said, probably, yeah, if you're at the level of bacteria, you probably don't need any intelligence. So Cornelius says, not true. Frequency is only relative to wavelength if the wave is continuous. If it is a sequence of pulses with gaps between them, they are not the same. I would probably still disagree with that. I mean, even if it comes in a sequence of pulses, I mean, it still has a wavelength. Now, I suppose that in order to determine frequency, you would have to put them together, I guess. cycles per second. I mean, you would have to take the one and then postulate how many of those would fit into 1 second's worth of time, and then that would be a frequency. Although, strictly speaking, in terms of, say, the way I think about it, so I think that the amplitude of any light wavelet is the same, and a frequency is only a matter of, you know, how often the peaks come, I guess. So I suppose you could have like a really short wavelength, but have the frequency be very, very sparse, I suppose. So in that way, I could see that possibly being the case. But otherwise, I see are intimately related here. So they say they do not have to be huge waves like earthquake waves. They can and are of subatomic size. And once again, I can't not conceive of a shear wave being a small thing. And so unless you can tell me how they could be a small thing, I can't agree with your assertion that they can be of subatomic size. So once again here, it's a little lonely here in the live room here. So I would encourage you to join me and Carl and come on the live naturalphilosophy.org, not unless you just love to hear the sound of my voice. And today it's really kind of obvious that I'm really the only one doing the speaking here. Now that may be because some of our main people who normally talk a lot, like Bill Lucas, isn't here, or because I'm doing what I'm doing, which is like a mailbag kind of response here, where we're just reading the emails and going over it. Although I was thinking some of you guys would have piped up and really objected to some of the things that were being said in the email, or some of the things I was saying, or at least had some comments about that. But that's what I'm looking for. So, but also just commenting frequently, that can work too. Like I said, we're just trying things out. So anything comes to the top of your head, let me know, and we'll go through the comments here. But so let's get back to the mailbox here and see what the next thing was. So it was suggested I can just show a Chrome tab. Okay, let's do that. Okay, I'm gonna show that a Chrome tab. Now, one thing about this whole thing that I got from David Taylor is that I wasn't really sure what his position was really. I mean, maybe from this little discussion here, I was able to determine that a little bit better. But initially, it didn't really seem like he had a point. Okay, I guess we got the message from Don Burdell here. Let's see here. You have asked the fundamental questions that are at the bottom of it all. Thank you for that. Until we get a handle on them, we'll never solve the mechanics of our universe. Your questions are where it all begins. I use the plenum because ether has a meaning I don't think correct. Plenum is a background-dependent concept, whereas ether is background-independent. The difference is between a string with beads versus a string with knots. Knots are nothing but string and are dependent on the string for their existence. Beads are independent of the string. If the beads move along the string, they experience resistance, i.e. drag. A knot can move along the string without drag because it is a string. Furthermore, the string is not moving while the knot is moving, and still there will be no friction drag. Well, that I totally don't get. So if I take a rope and I tie a knot in it, that knot is not going to move, right? It's not anything like a bead on a string, beads, I know I can move back and forth on the string. Knots do not move. By their nature, they are fixed in place. So not only is there, well, there can't be drag because there can't be any drag on something you can't move, right? And I can't ever conceive of a situation where the string itself is not moving and the knot is moving, not unless the knot is super, super duper loose. And certainly I'm thinking there's going to be masses of friction if you do that. So there's a lot in that statement that I would disagree with, right? So this is why my comment is that you can't have a moving knot, not unless you're a magician, and then they'll often do these rope tricks where they put the knot in and then they do something and the knot just flies off the rope, and you know it takes magic to do that. I guess is my response there. So and Don Riddell, he's his main thing is he thinks everything is knots. So as with most dissidents, we'll usually kind of fixate on one thing. You know, like Cornelius fixates on tension. I fixate on positron electrons. Don fixates on knots. And, you know, that's what we discuss here. All different from the mainstream. And that's what we're here to discuss. So let's see here. What's this question here? Nothing from Don Burdell. Okay. So Ian, you asked if I thought plenum had gravitation properties. My view is that all properties are traceable back to plenum, since all energy and matter localized are derived from the plenum. Well, I would certainly agree with that. However, gravity does not appear until mass appears. By twisting the plenum and literally tying it into knots to make matter, a tension is induced into the plenum. That tension is gravity. The plenum does not want to be condensed. It wants to be free of tension, so it tugs at the knot, thus entropy. Gravity is actually a pull. From the above description, it would seem that gravity we experience on Earth is centripetal instead of centrifugal. However, the tension has to be relieved by going toward the mass center. Hence, we experience gravity as a push force, forcing our mass into the Earth. I realize this is counterintuitive, but when you build a model, the way out is the way in. Mass holds the plenum and prevents it plenum from deploying. Mass holds the plenum and prevents it. Only by breaking the mass's knot can the plenum be relieved of its tension. Where does that happen? It happens at the center of the galaxy. The EM jets rising out of the galaxy center are the result of mass not breaking. The previous sketch of why gravity as it appears in field structure theory. Okay, well, while I can agree that, you know, the plenum, or e.g. the ether, they're traceable back to the plenum or the ether. Now, I don't know about his distinction between, so he thinks the ether, because it's like beads on a string versus knots in a string. I would say that, yeah, the ether actually is beads on a string. Well, actually, just beads. There doesn't need to be any string, is what I would say. So that's how I'd reply to them, that yeah, space, it doesn't have nothing to do with strings, and certainly doesn't have anything to do with knots. It's a particulate medium, is what I would say. Now, he does try and say that gravity has something to do with tension. So what is tension? So tension is when I take something and I stretch it or I twist it. This is presuming some sort of material that that can undergo certain forces, and they call it like tensile strength, that it has something to hold it together, like a piece of paper. So if I tension a piece of paper by pulling down the corners. That's what we mean by tension. Now, the question is, what does that have to do? I would argue it has nothing to do with the force of gravity. I would say that your logic here is completely missing. That he says that tension is gravity. If I grab hold of two pieces of paper and tug at the corners, and I call that gravity, well, that just makes about as much sense. It's like, well, what does that have to do with gravity? Where's the force? I mean, if I put like a ball on top of the paper and I tug it, will the ball like move towards one end of the paper? No, it won't. Generally speaking, the tension itself doesn't cause anything to move anywhere. Nothing is compelled to go from one place to the other due to tension. Tension is just a measurement of the stress of the atoms of the material that it's under. I mean, it doesn't create anything that could be a force, right? So you're saying tension is gravity. I pull a tug on the ends of my paper to create tension, and you're saying that's gravity. I'm saying that makes absolutely zero sense at all, right? There's no connection. There's no connection between tension and gravity. And now I just say gravity is a pull. It's like, well, I think most people think gravity is a pull. That is not under question. Although some people think gravity is actually a push, that there's particles coming down our head and it's actually pushing us down. But actually, in some ways, I would actually agree with that anything that looks like an attraction is actually due to a lower pressure being created beneath, a lower pressure being created between two objects that makes them come together because there's something still pushing on the outside. So, but it acts like a pull, right? So he makes a number of other statements here that just by English don't make sense. Mass holds the plenum and prevents it plenum from deploying. Well, that's not even a legal English sentence. Only by breaking the mass's knot can the plenum be relieved of its tension. And that doesn't make any sense, I don't think. How do you break a mass's knot? And why would the plenum be under tension because there's a knot in it? I can have a string with all kinds of knots in it. It's under no tension at all. Only by picking up the string and pulling on it do I create tension. So that's the message from Don about gravity and tension. So, if anybody has any comments on that, anyone had any comments on that? Let's see. We've got a couple comments here. Good. Looks like we've got a problem with naturalphilosophy.org. Max user connections are reached. So, David, you might want to check that. So, the medium, particulate nature, and the pulse duration of the originating event. In the case where the medium is continuous, then there is no restriction on how short the shear wave can be. Well, it's not a matter of shortness, but shear wave definitely occurs across large sections of the media, right? You can't have a shear wave restricted to like a bullet-sized object, I would guess. That's what I'm kind of getting at here. Although I suppose you could really pull it, you could really stretch it to think it would. But I think you're saying that a particulate medium would have that limitation, but where a medium is continuous, then there would be no restriction. And this once again getting back to the discussion of like when we started with Rogers thinking that the ether must be a completely uniform substance. But I would say that if it was completely uniform, then it would by definition be completely incapable of supporting any waves at all, because any wave would be in a non-uniformity, right? But I kind of appreciate that Cornelius, he's trying to talk about some kind of substance which is still able to mediate tension, but yet is completely continuous. I mean, not having any pieces, or if it has a piece, it has one piece. But once again, there's no such thing in our universe like that. Everything that we know of is made out of particles. So I think it's just more reasonable to think that the medium is made out of particles as well, and that the waves are normal compression waves, I would guess. So it's working now. Well, I guess, I mean, that must be referring to the website not working. All right. All right. Well, we're getting towards the end of our time here, so I think I'm going to wrap things up. So once again, thank you for showing up. Today we have at least 12 participants on YouTube here. Let me check the YouTube here. Yeah, 11 or 12. Good. Thanks for showing up. And I understand that today was a little unusual in that it was mostly just me as a talking head, but hopefully you heard some opinions from other people today from all the emails that are sent around. And it's actually quite a job just to keep up with these emails. I may get 20 or 30 emails a day, and but you can see I keep on up because they have interesting topics that are always happening, and so sometimes when there's no speaker for the science chat, I'm happy to bring those points to you so you can hear what other people are thinking. And then, of course, naturally, I'm highly opinionated, so I'll give my opinion and respond to all these emails. But that will do it for today. Like I said, if you have any questions or comments, you can send them to me. My email address is franklinhu@yahoo.com. And if you have any questions, like I said, questions, comments, and especially if you have something you would like to present, we would love to have you on the show so that it's just not me talking all the time. But I hope you enjoyed today's show, and we'll see you next time.